some vocab down here first. Combined variation. What would you imagine combined variation is?
We add them all together.
Yeah, it's combined variation is a variation equation that includes direct and inverse variation. Okay, so a variation equation that includes direct and inverse variation. Something like this, y equals k times x divided by z, where x and z are both considered to be independent variables, okay? So you're looking at the relationship, what do these two variables have an effect on your y value? Because remember we talked yesterday about how there's a lot of situations that there's more than one variable that really affect, what it is you're looking at. And then joint variation is just a little bit different. Joint variation is a variation equation that relates more than one independent variables to a dependent variable through direct variation. And that's really the big key here, is that for it to be considered joint variation, it's all direct, okay? But there's still more than one variable. Variation. Okay, so for joint variation, you're working with more than one variable, but it's all direct variation as opposed to this one, which has some inverse in it. So this would be something like this. Y equals k times x times z. Okay, so that is joint variation, when you've got one variable that's being affected by more than one thing, but it's all being multiplied together. Okay? Questions on that? Give me a second to finish writing that down. I'm probably still writing. Just as looking for us to get kind of a general relationship here. The time that it takes a parade to pass a reviewing stand. So you're watching a parade, and maybe don't even think of it as a reviewing stand. Think of it as you are standing on the side of the road watching a parade. And we're measuring the time from the moment the parade starts to the moment the parade ends. Okay? And this varies with two different things. It varies with the length of the parade, how long the parade is, and it varies with the speed, how quickly the parade is moving. So I just want to know in general, and again, I'm not giving you any actual numbers, so we can't talk square or cubed or anything, but in general, how are these things related? So the time and the length of the parade. As the time gets longer, as the length of the parade gets longer, what happens to your time? Longer. So what do we call that? Direct. So I would say that T varies directly with L. Okay? Now let's look at time versus speed. As your speed gets bigger, as your speed increases, what happens to your time? It would go down, right? Because if the parade is moving faster, then it's going to go past you faster, and so you won't be there for as much time. So what kind of variation is that? That's inverse, right? Because as speed gets bigger, time gets smaller. So T varies inversely with S. So a general variation equation here would be T equals what? How would I put these two things together? Drew? Really close. What am I missing that every variation equation has? There you go. Put your K in there. Yep. Those used to be my initials. Fun. So anything that's direct ends up in the numerator. Anything that's inverse ends up in the denominator. And then you need a K value in there as well. Is that too low? Sorry. Okay. And then, of course, if I gave you actual numbers, if I said if the parade is this long, you know, it's going to take this much time. If the parade is this long, it's going to take this much time. We could plug numbers in and actually find K values, but I didn't do that to you here. Okay? Okay. On to the back. The back we're talking about joint variation, which is really the same idea except all with one variable, or all with multiplication. It's all direct. And I just wanted to talk about some examples of joint variation with you, that things that you use or have used in the past that you maybe didn't realize were joint variation. Like, you know, Selena said, hey, that's a formula from chemistry. I recognize that. The same kind of thing exists all over the place. For example, what's that? That's area of a triangle, right? That's joint variation. The area depends on, or the area varies directly with the base and the height with a K value of 1/2. Okay? Even something like this, area equals length times width. That's technically joint variation too. Just what's your K value there?
1.
Your K value there would be 1. Yep. Can you think of any others?
The one I told.
Okay. And now that one, though, because it had a division in it, that has inverse in there,
okay.
too. So joint variation is all just multiplication.
All right.
Okay, so like, so really like volume, well, surface area of a sphere would be 4 pi. Well, this one actually would just be direct because 4 and pi is just like one constant. So that would be your whole K value. Pi is a constant. But if you did volume, oh, that's still, let's do volume of maybe a cylinder. So volume of a cylinder would be pi r squared h. Okay? So this is the area of the base and then multiplied by the height. So there's your K value, and then you've got two variables, two independent variables that affect the volume, right? Because if you increase the radius or if you increase the height, you're going to be increasing the volume. Okay? So I just wanted you to kind of get an idea that this is not a new thing. We're calling it something new, but you've seen this before. And now that I've said that to you and made you think that it's really easy, let's look at this blah, blah, blah problem with all these words and scary numbers in it. The wind force on a vertical surface varies jointly, so there's a new one for you, varies jointly, as the area of the surface and the square of the wind speed. So let's start by writing ourselves a general equation. That's always our first step, right? So my force varies jointly. So what does that mean my equation's going to look like? Yeah, it's going to be all multiplication. I'm going to have a K value, right? So K times area times the square of the wind speed, so that would be S squared. Does that make sense? That jointly is you're multiplying more than one thing, but it's still all multiplication. Okay? And then this is where they give you like one set of data. So remember, this is just like any other one of these problems you've ever seen, is I'm giving you one set of data. What do you think I'm going to do with all that information? Plug it all in and solve for, I need my K value, right? So now I'm going to say my force is 340. I don't know K. My area is 1 square meter. That makes my life a little easy. And then the wind blows 18 meters per second, so that'd be 18 squared. Everyone following okay what I did there? Yeah? Okay. I'm going to go ahead and put these all together. So now I have 340 equals, what's 18 squared? Someone have that, 18 squared?
The answer.
Yeah, what is that? 18 squared.
For the whole equation.
Oh, okay, what is it? 321? Oh, 324. Thank you. And then divide by 324. So Emily, is that the answer you have? When you divide by 324. Go ahead.
If I rounded it up, I got 1.1.
Okay. 1.1. I think that sounds reasonable. So my K value is 1.1. Okay. What's my third step then? So if I wanted to make like a formula, it would be 1.1 AS squared, right? And now I can go ahead and plug in the value that I actually want. So I want, what value is this? The 35. That goes in for what? That's my S. That's my speed. And then my area is over here of 2. So 1.1 times my area of 2 times 35 squared. I'm going to just rely on you for that. Anybody have it yet?
2,695.
Do we agree? Okay. And how are we measuring force in newtons? So that would be my final answer. So that's nothing new to you, right? I mean, that process, that's the same process we've done with all of these. Now it's just that you have more than one variable. But I still would have to give you values for all of those variables for you to solve for K. So really works the same way. Good? Questions on that at all? Okay. So we have one more new thing